Lesson 4.2, in which you learn why Margaret might teach music, might teach math, but will never teach drawing. I labeled this vocab-ish. We're about to get to some vocabulary, but first, I would like you to imagine a hydra. That's what this is. It's got 3 snake heads and a body. And here's a little guy with a sword ready to fight it. But he doesn't know the secret of the hydra, which of course you all know. After you chop off one head, here's one dead head, you end up with 2 more, right? So I would like you to think of this in these terms. You input 1 chopped off head. You output 2 new heads. In this example, 1 chopped off head is an independent variable. 2 is a dependent variable. Why? Because you chopped off 1, but because of the nature of the hydra, you ended up with 2. If you had chopped off 2, then you would have ended up with an output of 4 new heads, and that would have been your dependent variable. So now that you've got that, go ahead and make some note in your book. You can draw the hydra if you want. You can just say, think about a hydra, but you need to know input, output, independent variable, and dependent variable. The input is what you get when you put in. The output is what comes out of whatever process you're using. Now, problem 1. I am going to explain part of this a little differently than they did in the book. If this explanation makes sense, that's wonderful. If this explanation is not quite thorough enough, take a look at page 240 and look at it the way that they explain it, because I think between their explanation and my explanation, you'll probably get it. So, take 1 rectangular shaped building block. What's the perimeter of this? That's easy. 2 times the height plus 2 times the width gives you 14. Add more blocks, but do this in a more, shall we say, algebraic fashion. So now we still have 2 times 6. That stays constant, but we have 3 of these blocks. So now instead of 2 times 1, we're going to use 2 times 3, and our perimeter is 18. Now, the next step. The number of rectangles that we use is our input, and it is our x value, because we're about to graph this. The perimeter is our y value. That is going to be our output. So here it is in a little graph. If we put in 1 rectangle, we have an output, a perimeter, of 14. If we put in an input of 3 rectangles, our output is 18. If we start with an independent variable of 1 rectangle, our dependent variable is 14. If 3 is our independent variable, our output, our dependent variable, is 18. Now, take a look at page 241, step 2. The next step that they give you is describe the pattern that you've created in words so that you can write an equation. They give you multiply the number of rectangles in each figure by 2 to get the length, then add, la 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 la. Here's the equation. The output is 2 times the input plus 12. The total perimeter is 2 times the number of rectangles plus 12. Then they want you to use the information from the table to make a graph. So, with 1 rectangle, we have a perimeter of 14. With 2 rectangles, a perimeter of 16, and so on. As we started to talk about in the last chapter, x-axis for the independent variable, the one that moves steadily, y-axis for the dependent variable. Remember the last graph you did, I said use x-axis for time because time moves steadily, and because the height of the rocket flight depended on time, use the y-axis for time. And now we are ready to tackle got it number 1. Whew. In the diagram, what's the relationship between the number of triangles and the perimeter of the figure? This is not just add it up, count it up, and tell me the number answer. I need to see a table, I need to see the equation, I need to see a graph. If you can do table, equation, and graph, I know you can do words. If you are unable to do one of those, give me the words, and then we'll go from there. It's the same problem that they just went through with the rectangles, so if you're confused, look back, try it again. I'll be waiting. All right, here's the whole thing. I gave you the table first. Notice each column is labeled. That's important. The number of triangles, which is going to be our x value, I put here. 1, 2, 3, or 4 triangles. The perimeter of the whole diagram, which is going to be our y value, I put here. And then I went ahead and just combined those two numbers so that I would be able to keep track of what my points are to plot on a graph. I gave you the words so that you would have them. What is your equation going to be? You're going to multiply the number of triangles by 4, and then you're going to add 6. What's your equation going to be? Y equals 4x plus 6. X is our number of triangles. Multiply the number of triangles by 4, 4x. Then add 6 right there. Why are we adding 6? Think about it. Make sure you know. Don't go on until you do. That's okay. We'll wait. All right. The graph for this is going to look like this. And all I did was take these points that I had figured out up here. 110, 114, 118, 122. Hey, is anybody else noticing a huge mistake here? This one doesn't count because I caught it while filming. That should be 214, that should be 318, and that should be 422. I graphed it right. Yikes. Okay? That's what your graph will look like. Remember, I do not have to have the words if you understand enough to give me a table, an equation, and a graph. All right, I apologize. I got so excited, with the Hydra and graphing stuff that I forgot to give you the rest of the vocabulary. Here it is. A function is a relationship that pairs one input with one output. You've actually already looked at 2 of them in this chapter. The equation to figure out how big the perimeter of the rectangle thing was a function. Same with the triangle problem. One input gives you one output. A linear function, it's your second vocabulary term, or I should say your next vocabulary term, is a function that graphs as a straight line. And this is important, but it won't make any sense to you yet. It needs to be a non-vertical line. A function that graphs as a straight line. For example, this one. That's a linear function. That's a straight line. The graphs we were looking at in the last chapter are not, most of them, linear. They were curved, the rocket went up, came down, not linear. They drew a cute little diagram for you here. This is a function machine. You put an input or an independent variable in at the top of the machine, you apply the function, which gives exactly one output per input, and then boop, out comes the output. So problem 2, they give you the relationship between the number of photos that you take and the memory that you use. And the only question they ask is this a linear function? Then they want you to describe the relationship using words, equation, and a graph. Again, if you can do the equation, the graph, I don't need the words. Here's where they show something quite useful, how to figure out what your equation is going to be. Every time you add you take another photo, you add simply just 1. Every time you take another photo, you take away 3 megabytes of memory. So, in words, the amount of memory is 512 minus 3 times the number of photos taken. And there's your equation, 512 minus 3x. And again, you have to do it this way. Just using arithmetic and giving me the right answer at the end does not count. Then they show you the graph. Once you see those points in a line, you know that this is a linear function. Try this on your own. Got it number 2 is the relationship on this table on page 242, a linear function. Words if you need them, an equation, and a graph. So the words that you used or thought through should have looked something like this: multiply x by 2 and add 8. That's a little bit flexible. This is not. Y equals 2x plus 8. That's the equation you need. Then, using the points that they gave in the chart, show me on a graph. 0, 8, 1, 10, 2, 12, yep, and 3, 14. Now I'm paranoid checking for mistakes all the time. And you can see that's a line. This is going to be a linear graph. Forgot it, number 2 still, problem B. They gave you a reasoning, which you usually don't have to write out. I thought a picture was worth 1,000 words, so I wrote it out. They gave you 3 points, 0, 2, 1, 4, and 3, 5. Does that represent a linear function? Well, can you make one line that includes all of those points? No, you can't. You cannot make one straight line, so that is not representing a linear function. Finish it up, please, with a lesson check on page 243. Now, the math in this is very, very simple. I need to know that you can draw these graphs, figure out these equations, and it all makes sense to you. If you don't feel confident of that, then talk to me for some extra help tomorrow.